It's Mr. Chauncy, the magic hippo, teaching about how science works. It's Mr. Chauncy, that's one magic hippo, emerging from where Chauncy lurks.
Science, at its heart, is learning about our environment through observation and experimentation. A claim about the world needs to be substantiated by observable results. Science depends upon the way claims and results are connected. Let's discuss the logic of this connection. Suppose we have two claims about the world, A and B. A could mean Bob is from Saskatchewan. B, another claim, could mean Bob is from Canada. We can relate these two claims into what is known as a conditional claim. If Bob is from Saskatchewan, then Bob is from Canada. Or simply, if A, then B. Let's say we know that Bob is from Saskatchewan, the easiest province to draw. Since Saskatchewan is a subset of all of Canada, which is hard to draw, then we can conclude B, or that Bob is from Canada. Now suppose we know not B. Bob is not from Canada. Because of our logical connection, we would also be able to conclude that Bob is not from Saskatchewan. We run into some issues if we start by knowing B, that Bob is from Canada. This knowledge won't let us conclude anything definitive about whether or not Bob is from Saskatchewan. The possibility remains open, however, which is an important point. We run into the same problem when we start with not A. Knowing that Bob is not from Saskatchewan does not let us conclude anything definitive about whether or not Bob is from Canada. Summarizing the conditional claim, if A then B, proving A leads to B, proving not B leads to not A, proving B allows us to conclude nothing certain of A. Similarly, proving not A lets us conclude nothing of B. But what does any of this have to do with the scientific method? Suppose Bob were in Saskatchewan and wondered about the world around him. He might formulate a hypothesis, or a claim, that the world was flat, perhaps understandable since he is in Saskatchewan. If this hypothesis were true, then Bob should be able to find the edge of the world, where he could jump right off. So Bob goes for a big walk and, although he did find Manitoba, he did not find the end of the world. Because Bob did not get the results he wanted, he concluded that his hypothesis was flawed. Not B led Bob to conclude not A, or that the world was not flat. The community plays an important role in science. Bob's findings needed to be repeated by independent researchers who wished to validate his results. In this case, no researchers found the edge. Someone else had a different hypothesis, to which Bob and his friends can now turn their attention. The world could be a sphere. Bob and his friends think up a test for this new hypothesis. Every now and then, the moon passes through the Earth's shadow in what is known as a lunar eclipse. If the Earth were a sphere, then the observable shadow should always be round. If the Earth were a flat disk shape, then, depending on the angle of the Earth, we should sometimes observe an oval shape. Time after time, however, only round shadows are observed on the moon, and no ovals. This predicted observation could be considered evidence that the Earth is round. Although our logical connection does not let us conclude specifically that the Earth is a sphere, Bob and his friends have some evidence. Other tests are thought up that would provide even more evidence. These tests are conducted and observations are made. Eventually, when the multiple predictions are confirmed by multiple researchers, we can conclude that there is enough evidence that the world is indeed a sphere.
For more information about the scientific method, Google a guy named Carl Hempel. It's Mr. Chauncy, the magic hippo, teaching about how science works. It's Mr. Chauncy, that's one magic hippo, emerging from where Chauncy lurks.